very much. I will be explaining part of the result from this research paper. So part of the result that I will be explaining will be the effect of the bubble coefficient and the gas velocity on the average bubble size and the bubbles number. So like Tophet has mentioned, bubble coefficient, okay, in simple terms, when the two small bubbles collide together to form a bigger bubbles, you call it bubble coefficient. So when the bubble break up, when the bigger bubbles breaks into two. So from this diagram, from this graph, you can see that the bubble size increases with the axial position, while the number of bubbles per liter decreases. Why? If the bubble size is increasing, it simply means there is more of what bubble coefficient process, and then the number of bubbles is decreasing. Thank you very much. I will be explaining part of the result from this research paper. So part of the result that I will be explaining will be the effect of the bubble coefficient and the gas velocity on the average bubble size and the bubbles number. So like Tophet has mentioned, bubble coefficient, okay, in simple terms, when the two small bubbles collide together to form a bigger bubbles, you call it bubble coefficient. So when the bubble break up, when the bigger bubbles breaks into two. So from this diagram, from this graph, you can see that the bubble size increases with the axial position, while the number of bubbles per liter decreases. Why? If the bubble size is increasing, it simply means there is more of what bubble coefficient process, and then the number of bubbles is decreasing, meaning that two bubbles are coming together to form bigger bubbles, right? So it simply means the basic reasons why you have the bubble coefficient, why you have the bubble size decreasing, increasing, and the number of bubbles per liter decreasing is because of there is more of bubble coefficient process than what bubbles break up. So in terms of the gas velocity, we can actually see here that at a very low gas velocity, there tends to be an increase in the bubble size. Okay, so the major reasons behind that is because as the gas velocity increases, the amount of the bubble size also increases. Okay, and then there's also another reasons for this effect of the gas velocity. One of the reason is that as this keeps increasing to a gas velocity of 8.37, okay, there seems to be, according to this study, there seems to be a kind of bubbles breakup. So, but beyond this gas velocity of beyond the gas velocity of 8.37, there tends to be a kind of dynamic equilibrium between the bubble coefficient and bubble breakup. So this dynamic equilibrium is due to the fact that there is a kind of a stability of the bubble size. Okay, but that does not mean that the number of bubbles will not increase because you are increasing the gas velocity. So the second result I will explain will be the radial distribution of the average bubble size on the columns wall. If you look at these diagrams very well, this graph very well, we find out that the bubble size has a uniform distribution on the columns walls of the bubbles induced three-phase fluidized in a bed. But nearer to the wall, there seems to be a decrease of the bubble size. The question is why? It's because if you look at here, larger bubbles tend to move away from the walls due to the walls effect. So that was the basic explanation of this behavior that was obtained in this result. Now, like I'm supposed to actually give you a kind of brief result that were obtained from this research. One of it was that they had to find a way to calculate the bubble rise velocity. Secondly, they have to look at the effect of bubble coalescence on the walls of this BIF bubble-induced fluidized bed. Now, if you look at this graph, you'll find out that the bubble size increases with the bubble's rise velocity and also with the gas velocity. So this was part of the result that were found in this. And from that, they were able to develop a correlation. They were able to develop an equation that can calculate the bubble rise velocity. Now, how did they do that? When they did an experimental experiment, they got a value of their K value to be 0.9614, which was closer to Rapin's correlations. Okay, theoretical data of 0.914. So, and then they plotted the correlated bubble rise velocity against the experimental velocity. And then they got an error of plus or minus 15%. So they now formulated that this equation can be used to actually calculate the bubble rise velocity in this bubble induced three-phase fluidized bed. Now, another interesting thing that was obtained here is the gas holdup. What's the gas holdup? Gas holdup is a fraction of gas of the total volume. So what did they do? They have to also, because gas holdup is very important to understand the gas distribution in the bed. So they have to actually look for an equation that can be used to calculate the gas holdup. So from that, they did a plot between the gas holdup and the superficial gas velocity, and then they find out that the gas holdup increases with the superficial gas velocity. And then in that, they now did this correlated data, they now use it to compare with their experimental data to find that the result varies with just 6%. And this equation was now derived from their calculation to actually use to calculate the gas holdup in this bubble-induced fluidized bed. Now, this research paper was talking about determining the bubble size and bubble rise velocity in bubble-induced three-phase inverse fluidized bed. And then interesting results were obtained. One of the interesting results that was obtained is that due to the bubble behavior, particles moves into 4 different region transitions. Okay, so that was one. Secondly, a normal bubble coalescence, like I said, bubble coalescence and bubble breakup was observed in this bubbling induced fluidized bed. And then another thing that was done that was very interesting is that from their experimental data and the correlation with theoretical data, they were able to actually arrive at an equation that can be used to calculate the bubble rise velocity. So, you know, one of the techniques they used was by using the new telecentric photographic probe to actually measure this in this pilot scale BIF bed. So this actually gives us an understanding of the fluid bed dynamics in this experiment. Thank you very much.
Thank you.